The use of stumps for bioenergy is fairly new to Swedish forestry, even though stump extraction has been practiced since medieval times. Pine stumps were extracted to produce wood tar until the early 20th century. Later, in the 1980s, spruce stumps were lifted for use in the pulp industry. Lifting methods have been developed over the centuries, although nothing much has happened on that front since the 1980s. The most commonly used machines are 20 to 25-ton tracked excavators, equipped with some kind of specialized stump extraction unit at the boom tip. Spruce stumps are the preferred stumps, while some pine is also lifted. Hardwood stumps are, however, always left untouched. A wide variety of extraction units are used, from very simple fork-like grapples to sophisticated multi-grip harvesting units. The general idea with them all is to enable the machine operator to grip, split and pile the stumps as easily and smoothly as possible. The work involves positioning the excavator so it can reach several stumps without the boom having to be stretched to a maximum, which would imperil stability. The operator then grips the stump from the top, if the stump is small, while with bigger stumps, one of the large root buttresses usually offers the best option for gripping. Once it's gripped, the operator starts to pull and lift simultaneously until the stump comes loose. Often it will break up into several pieces during this operation, and those pieces will have to be picked up and piled one by one. Generally, the stumps are more or less contaminated with stones, sand and dirt, which will have to be shaken off before piling. Large stump parts are also split into smaller parts to facilitate cleaning and drying. The piled stump parts are now left at the site for a few weeks to allow the weather to wash more impurities off before forwarding to landing. Forwarding stumps is done with the same type of specially equipped forwarders that are used for slash. Since stump parts are bulky and impossible to compact, even a very big load generally doesn't weigh that much, in this case less than 10 tons. Contrary to most other forest assortments, stumps should not be unloaded cautiously. In fact, it's better to just throw them off. The rough handling will help shake off more impurities, thus reducing ash content at the power plant. At this point, there are two options as regards further transportation. The stump parts can either be loaded onto a reinforced truck to be transported to a terminal or heating plant for comminution. Or they can be ground at landing, and the chips then transported on trucks. This method increases load weight significantly for the trucks, thus reducing transportation costs, as well as opening up other options. It is perfectly possible to run the chips through a drum sieve directly after grinding. This will result in a much cleaner material to deliver to the heating plant, with an ash content of under 5%, which is seldom achievable without a sieve. Another advantage is that the terminal or heating plant won't have to dispose of large amounts of non-combustible material, a process which can be very costly. Stump extraction is still at the development stage in Sweden, both with regard to the technology and the methods used. A lot of work needs to be done on the lifting method in particular, to make it more economical and more gentle to the ground. It's hard to say anything specific regarding what this equipment might actually look like, but research is in progress to find something that can loosen the stumps without having to apply the kind of brute force currently in use. After all, stump wood is estimated to account for 20 to 30 terawatt-hours of energy yearly, if utilized to the extent thought reasonable by the Swedish Forest Agency 2008. That corresponds to 25 to 30% of the total amount of biofuels used annually in Sweden.